Hey guys, if you're working with NATS JetStream, you might have heard about mirror streams. But what exactly are they, and why should you care? In this video, we're breaking down what you need to know about mirror streams, how they work, when to use them, and the gotchas you should look out for. Let's dive in. At its core, a mirror stream is pretty straightforward. It's a replica of another stream that automatically and asynchronously syncs messages from an origin. Think of it like a one-way mirror. Data flows in, but only from the origin. Let's talk about what makes mirror streams special. First, each mirror can only replicate from a single origin stream. It's a strict one-to-one relationship. Second, mirrors are read-only. Your clients can't directly publish to them. But don't worry, you can still delete messages on demand if you need to. And consumers have full capabilities, just like on regular streams. Third, mirror streams preserve the original metadata. They keep the sequence numbers and timestamps from the original stream. So if a message was sequence number 42 in the origin, it'll be 42 in the mirror also. And fourth, configuration is all done on the receiving side. Your origin stream doesn't need any special setup. It won't even see a consumer created for the replication. When you're setting up a mirror, you've got several options. The only required field is the name field, the name of the stream you want to mirror. But you can also get fancy with some optional parameters. Start sequence lets you pick a starting sequence number if you don't want to mirror from the beginning. Start time does the same thing, but based on a timestamp. Filter subject narrows things down to just messages that match a specific subject pattern. Useful if you only care about certain topics. Subject transforms lets you transform subject names as messages are replicated. Great for remapping topics. And domain specifies which JetStream domain the origin stream lives in. Useful for hub and leaf topologies. One thing to remember, you can't use filter subject and subject transform together. You gotta pick one. So when would you actually use mirror streams? Geographic distribution is a big one. Spin up mirror streams in different regions to bring data closer to where it's needed. One origin stream can feed multiple mirrors, perfect for fan-out topologies that serve millions of client connections. Mirror streams are also great for cross-account scenarios where you need to replicate data across different NATS accounts or domains. You can also use mirrors for load distribution by enabling the Mirror Direct Stream attribute. With Mirror Direct, clients can read directly from the mirror replicas instead of being routed back to the origin. So you can spread read load across multiple replicas instead of hammering a single stream. Now let's talk about what you can't do with mirrors, because this is important. First, changes to the mirror don't flow backward to the origin. If you delete messages from the mirror, the origin stream is unaffected. And that's by design. Mirrors are one way only. Second, deletes in the origin stream are not replicated. So if your origin removes messages, those deletions don't show up in the mirror. Third, there are some edge cases with special retention policies. If your origin stream uses work queue retention, mirror support is only partial and not resilient over intermittent connections like leaf nodes. With that said, mirrors are generally tolerant of the origin being temporarily unreachable. When the connection drops, the mirror waits about 10 to 20 seconds before retrying. And if you're using interest-based retention, don't try it. Mirror streams don't officially support that, and the behavior is undefined. All right, let's do a quick demo of some mirror functionality. We're going to be using this setup. We'll have 3 clusters, and we're going to make a stream on cluster C1 and a stream mirror on cluster C2. And we're going to watch everything as we do this. We're going to run this command here. This is going to use the Linux terminal watch command to continuously run NATS stream report. So when we run this command, we would normally get a nice little handy dandy report back, but we haven't made any streams yet. So let's do that. I'll quickly make 2 streams, the first one being the normal stream on cluster C1. And our watch command picked it up, and you can see we have the event stream created here on cluster C1. And now let's create the mirror stream. Cool. It looks like our watch command is picking it up, and you see the mirror stream created here, events 2. And this is backed by this little replication report here. We can see events 2, and it's a mirror stream. Now let's publish a few messages to the primary stream. We'll just copy these 3 pub messages and send them through. If we look at the stream report, we can see both streams now show 3 messages. The mirror has replicated everything from the primary. Let's confirm by reading the last message from the mirror. And there it is, the gizmo message replicated from the primary. An important property of mirrors, they're read-only. You can't publish directly to them. So let's try it. We're going to make a request to send a message to our mirror stream. And as expected, that fails. And you can see here it says expected stream does not match because mirrors only pull from the origin. Let's run that same command again, but this time publish to our primary stream. And we can see this time it worked. We can even confirm that in our stream report because now both streams have 4 messages. Mirrors also preserve metadata, like sequence numbers and timestamps. Let's compare the state of both streams. We'll get the stream info for both streams in JSON form, and then we'll pipe that to JQ and pull out the state key. And if we do that, we'll get the metadata for each stream in a nice little format. And notice the sequence numbers and timestamps match. The mirror is a faithful copy of the origin. And here's another key behavior. Deletes are not replicated between the origin and the mirror. They're independent. Let's do something to show this real quick. So first we'll delete message 2 from the origin, and then we'll confirm it's gone. So I'll just copy these 2 statements really quick, and this should confirm that the message is deleted. So we try to get message 2, and we can see we're not able to get it because it doesn't exist. And we can also see our primary stream now has 3 messages in it, but our mirror stream still has 4. Let's get that second message from the mirror stream. And confirmed, it's still there. Now let's do the reverse. Let's delete message 1 from the mirror. So let's copy this and delete message 1 from the mirror. And we can see the mirror has 3 messages now. And then try to get it from the primary stream. And there it is intact. Deletes on one side don't affect the other. This makes mirrors useful as independent backups. Now here's something exciting that landed in NATS 2.12. Mirror promotion. If your origin stream goes down permanently, you can promote a mirror to become the new primary. The process is, first, unbind subjects from the old primary so you don't have 2 streams competing for the same subjects. Then, remove the mirror configuration from the mirror and bind the subjects to it. Once the promoted stream is healthy, you can clean up the old one. Keep in mind the server won't verify if the mirror is fully caught up, so any unreplicated messages will be lost. This is what it looks like. Alright, let's show off mirror promotion. This is a really cool feature. First, we'll start a continuous publisher sending messages to the primary stream so we can see the promotion happen live. So messages will start flowing into the primary and replicating into the mirror in real time. And there we go, they're flowing in, and you'll see the messages are increasing. And now, to promote the mirror, the first step is to unbind the subjects from the primary stream. We'll set the subjects to dev null, a special placeholder that keeps the stream valid but stops it from accepting new publishes on the original subjects. And then we'll edit the mirror stream and promote it to a regular stream. And we're doing this so we don't have any hiccups during this transition period while we promote the mirror stream. And just like that, Events 2 is now the new primary stream. Take note of the message count for each of the streams. Now our original primary stream events isn't increasing. And since we promoted our Events 2 stream, it's now receiving all the messages. And if we want, we can go ahead and delete our original stream. So let's do that real quick. And our stream report confirms it. Events 2 is now accepting writes directly. Pretty cool. And I always like to do a little bit of code with these demos, so I wrote a little Go program that shows off some of this stuff. So what are we doing here? First, I just set up my NATS connection. Then I create my primary stream events and a mirror of it called events mirror. Then we publish 5 messages to the primary and then read them back from the mirror. Then I compare the metadata of both of them. I confirm that mirrors are read-only, and I show again that deletes don't replicate. And here's the output of that little program. It looks like all the events line up. The metadata also looks congruent. Confirm that the client couldn't publish to the mirror. And our message was deleted from our primary stream, but is still present in our mirror. So dumb little program, but fun little exercise. So to recap, mirror streams are your go-to for one-way replication of JetStream data across regions and unreliable networks without the complexity of full synchronization. Just remember, they're read-only, deletes don't replicate in either direction, and they work best with standard retention policies. If you've got questions about mirror streams or want to see them in action, drop a comment below, and if this helped, please hit that like and subscribe button. Thanks for watching.